Okay, guys, this video is about making a hex socket wrench. You can read there. It's a 4.5 inch hex socket wrench. I want to, all right? And see what this says here? Using CAD to plan your work. Let me give you a little background. I've been machining for a lot of years, right? I was machining before Dracula could count. You understand? Way back when. And there's no way I can make the simplest pot without a drawing, right? In the meantime, I'm a YouTube junkie, and I see guys making pots without drawings. And they say, well, I'm going to take this and flip that and do this and do a 1.5. I can't do that, you know? But I watch them. Some of them are successful at it, and some of them make junk. My opinion is a good drawing gives you good results. A bad drawing gives you bad results. All right? So, uh, you know, uh, let me take you where I'm going. See where it says 4.5 inch hex socket wrench? Let me blow this up. See this shape here? That's basically what it looks like in one view. A hex and an outer diameter. Got a hex in the middle here to drive it. You see it? I'm going to show you how to get all that done. All right? I say this. When you draw it, if you got machining skills and drawing skills, when you're drawing it, you're actually machining it in your head, and you make the adjustments to make it easier for a machinist. In a normal factory environment, some guy knows how to draw, the other guy knows how to machine. They're really not compatible to each other. If you're lucky enough to know CAD and do machining, you got a hell of an advantage. Let me start here. See what this says? I'm going to show you how to make this hex. It says subject pot inscribed circle. See, that's the key. Put a pin in that. Inscribed circle, almost like a tool bag, carbide tool. Here's a hex. Some guy walks up to you or some company, either somewhere, this hex is presented to you. I'm showing you one here that says 4.500. It could be 4.642, or it could be any size. This inscribed circle works no matter what. If you're making one pot fit the other, inscribed circle is the ticket. You understand? And I'm going to show you how to develop the hex for that. I put another one here under it. 3 inches, 625. Happens to be a kind of a standard size, but whatever. It doesn't matter, all right? So, you see this? This 4.500, half of that is 2.250. All right? Let me do this. I'm going to put an inscribed circle in there, okay? Hang on. See how this inscribed circle is the same size as the hex, right? Just want you to see that, okay? Let me get that out of there. I'm going to go down to the next one, just to be repetitive. You see that? 1 inch, 8125. Let me do that. Another inscribed circle. You see it? Same thing. Tangent to the hex, right? Let me get that out of the way. Okay, you say, hey Jim, well, what the hell good is that? Let me show you. Right? I took the inscribed circle and I put it out here, right? Now I'm going to show you how to make the hex. See, it says inside diameter 4.500, like that. Build the hex, right? I'm going to show you how to do that around that circle. It's really Mickey Mouse. All right? Let me do this. Lines. I put it outside the circle, all right? I'm going to show you how to build a hex around it. It's really simple using CAD. I'm going to measure from the line to the circle. See it? 0.4053. I'm going to transpose it to make it go tangent. Okay, let me get rid of the numbers. All right, you see it's tangent? Now I'm going to build a hex around it. Watch how easy this is. Here we go. See that mishmash? Now I'm going to get all the ends, trim all the ends off. Like I say, doesn't matter what the hex measures, you can get this perfect by using CAD without going to the machinery handbook and chasing your tail. All right? Let's see how big this circle is. Hang on, I'm going to make it red. See it? It's the same as that one. And I got it from the inscribed circle. Well, I'll leave it there. Want me to do it? I'll do it again for this one, all right? Just to be redundant so you get it, all right? Ah, I want it black. Hang on. .4864. All right, let me get the. All right. Now I'm gonna build the hex around that like I did before. You can see it twice. How the fuck does he do it? Let me trim it up. You see that? Well, let me get over here. See that width? 3.625. I'm going to have the same thing here. See how easy that is? Just want to let you know. Alright. So I built the hex around both of them. You see how easy that was. Alright? I'm going to go over here. Now that we got the inscribed circle, right? I'm going to show you what it's going to look like. I'm trying to figure out what the hell I'm talking about, alright? Alright, I'm showing you a view of, oh yeah, we're going to build an OD. I wanted a wall. I wanted a 1-inch wall. You see it from there to there. See that? 1 inch. That's sufficient. Alright? I'm showing you a picture of the pot now. You see these two holes? I put them in there to hold it down on a rotary table. That's going to have T-nuts under it and a hex nut on the top. What I did was, I'm showing the hex. I'm showing a hex here with an inscribed circle there. Showing you both, right? Yeah, I'm going to show you how easy it is to make this. Just a turned pot. You see it here? Well, I'm showing a cross section. You see it like I cut it across this way, right? All them hash marks are showing you where the cut is. This hex is 2 inches deep. You see it? 2 inches, 520 tall. That's the total height. 520 down here is the wall thickness, and the diameter is 6.5 inch diameter. You see that? Alright, now I'm going to show you the bottom view. You're going to see the 2 hold-down holes for the rotary table, and you're seeing the hex and the inscribed circle both together. All right, let me take you down a little lower. Here's what I'm gonna do. I don't know if I showed you this or not. Let me see. What the hell did I do? It doesn't matter. I'm showing you all of you. I'll show you this a little later. But here's the way you're going to do it. We're going to coax that hole, get the center of it, and we're gonna drill. See up here? 1/8 diameter hole, 6 places. That's going through 520 thousandths. A little deeper than a 1/2 inch. 1/8 drill right through. See it here? 6 places. Alright? The end mill. The end mill, oh yeah, see the end mill? The end mill's 250 in 6 places. I got the coordinates here. Hang on, I'm gonna put the hole in. Let me get out of it. Let me make it black so you can see it. You're going to drop an end mill in there at those locations. Once the end mill's done going 2 inches deep, this is all you're going to have left. You see this little area? Almost nothing left. You see it? Let me see what the bottom looks like. All right. All right. When you're done, this is what it's going to look like. The hex to drive it with. You see it? All you're going to do is you're going to move it. You're going to move that with an end mill. Let me just do this. Show you how to move the end mill. You know where these locations are. You're going to move the end mill from left to right or from right to left. It doesn't matter. All right? Let me do this. All right, let me do this. I'm going to move this 2833 to the right. I'm going to go slow just to make believe. See it? That's all you're going to do till you hit the right spot. Piece of cake. No trig, no fucking storage, just a rotary table. All right, I hope that makes sense to you. Let me see what I'm doing here. Let me clean this mess up. All right, you getting my drift? So, all right, now let me moving on quickly now. Obviously, I'm showing you this. You know, anybody can turn this up. You see it? That's 6.5 diameter, 4.5 bore, 3/4 inch ID, scribe circle. You can see that. Over here, I sectioned it. I might have just said that. See the section marks here? It's showing the 2 holes to bolt it down to the rotary table. You can see them here. All right? All right. Now, let me see what the hell I got here. I'm showing this here. I'm going to show you how the bigger one gets it, just like the 3/4 inch got it. Let me do this. Well, let me go back. Maybe I can. You're going to put your 3/4 inch end mill in that position and make it go over to the left. I'll do it slowly for you. See? So you'll be milling that off. Just a Mickey Mouse demonstration. Hang on, I'm just cleaning it up. You gotta be patient. That's what it's gonna look like, right? All the way around. I'm not gonna do every one, all right? So now, I'll show you how we're gonna get there. Well, it comes to the rotary table part of it. I'm showing you a rotary table that I own, that I imported into this video. I make drawings of all my accessory tools, vices, rotary tables, blah, blah, blah. And I import them into the videos when I need them, all right? So this is a 14-inch rotary table. You could do the same job with an 8-inch. I only got a drawing for a 14, so I'm going to use it. All right? All right. Over here, let me show you what I'm doing. You see, I got the 14, I'm showing the 14-inch table here. See it? With this mounted on it, with this piece. Right here, or this piece, mounted on it. Hex nut, half-inch hex nut, T-slots, you can see it. Got an arrow here, right? All we're gonna do is rotate, all right? Put a tool in, do your drilling, and then rotate, all right? Just showing you that. Now, I made this to simulate that so I don't have so much complicated bullshit to do. Let me do this. I'm going to rotate this. I think I got it right. Ah, you asshole. I copied it. I shouldn't have. Okay. Hang on. Stage fright. Okay. You see this? Now let me explain something. On the rotary table, when you turn this clockwise, the table turns this way, clockwise. You zero it up. I don't know which way, but you can figure it out. Anyways, what I'm going to do is I'm going to make believe. Okay, let me do this. I'll put a putting a pivot point on every one. All right? All right. What I'm going to do is put a drill right at this point and drill it 2 inches deep. Then I'm going to index it so this goes to the right. Obviously, the rotary table is going to be set at 0. See the arrows pointing to the 60? The next number's up. The drill is still there. You haven't moved the drill. All right? You're going to drill 2 inches deep. Go to the next one, only by rotating. The drill is still in the spindle. Hasn't moved on the XY either way, okay? See it? You're at 120 now. That drill is still in that location. You understand? All right? So you're going to go all the way around it without moving the drill or the XY table. Just rotate it 60 degrees, drill it 2 inches deep, flat bottom or whatever, okay? All right. I'm going to get it back to the 0. We don't have to do this again. See it? Okay? So I've used the 5/8 drill. Let me put it. Let me measure it for you. Dimension horizontal. See it? 5/8 drill, 2 inches deep. All right. Now I'm gonna put in the other one, the end mill, to create this. Hang on now. I'm winging this. There's the X there. Now I'm going to put a 3/4 inch end mill in there. All right? I'm going to get this circle out of here. It's distracting me. All right. Now this is going to be a 3/4 inch end mill, 2 inches deep. Okay, hang on. Hang on. God damn it, I keep making the sound. I want it black. You notice? Let me project them. I see that line. I want to project it. See it? It shows that that end mill is tangent to that hex. You see it there? Just wanted to make that point. All right? So now what we're going to do, I'm going to rotate it all around. Now it's going to be the same routine. Going to put the end mill in that one location and rotate the table. Instead of rotating the whole thing, I'm going to rotate the end mill, just to make life a little easier. What the hell happened? Let me try it again. See it? Same routine. Put the end mill in there, 2 inches deep. Rotate the table 60 degrees, 2 inches deep. Go all the way around it, and you end up with that. So when you're done, that's what you got. You see it? Let me get this out of the way. When you're done, let me see. It's gonna. What the hell's it gonna look like? I think I got it right. I forget the numbers. Let's see if I can. If my memory's worth the shit. Tell me. Oh yeah. I'm gonna have to measure it before I do it. Two inches, 250. Okay, I'm gonna show you what it's gonna look like. When you're done milling it. That's what it's gonna look like. Alright? And it's gonna be perfect. Does that make any sense to you? Alright? But that's how I plan it. But let me just cover a little more ground. Like I said, here's the rotary table. These are the pivot points. See all the little X's? That's a 1/2 inch hex nut into the rotary table. You're going to get this thing, this piece, clocked in or indicated concentric with the table. And that's how easy that is. That's the way it looks to me. If you guys want, how about putting in a comment? All right? All right. Hang on.